In this video, I am going to show you how to describe the end behavior of the functions g of x is equal to negative 2x cubed and h of x is equal to e over x to the fifth power. Finding the end behavior means that you are going to describe endpoints of a function when graphed, that it expands continuously and reaches out of bounds on a standard graphing chart. Let's find the end behavior for the graph of g of x is equal to negative 2x cubed. I can visualize what would the graph of negative 2x cubed look like because I can remember how the parent function of negative 2x cubed, which is only x cubed, looks like. I can determine that this function is translated across the x-axis and it is vertically stretched by 2. If you can't visualize this function like the way I do, you can use a graphing calculator to graph g of x is equal to negative 2x cubed. So the end behavior for this function is as the x values reach positive infinity, the values of g of x reach negative infinity. And as the x values reach negative infinity, the values of g of x reach positive infinity. So there you have found the end behavior for g of x is equal to negative 2x cubed. Now let's find the other one. The second function, which is this, I can't visualize this in my mind because the function is more complicated than the first one. You can see here that h of x is equal to the value of e divided by x to the power of 5. Recall that e is natural base function or a natural logarithm. I will use the help of a graphing calculator to graph the entire second function and see what the actual graph looks like before determining the end behavior. So on the graphing calculator, you want to graph the function h of x is equal to e over x to the fifth power. So the first thing you have to do here is press the y equals button and it will lead you to the screen. And you can see that I have already inputted the function. So let me reverse what I did. So the first thing you have to do is press the second button, which is here. And then it will show you an arrow pointing up and go to the division button, because in this division button is where the e value is at. So you can see in here. So press that and it will lead you to this. Press the division button again and it will show you that. Then the last thing we have to do here is input x to the fifth power. So press this button and then press this and then press 5. So this is the function that we need to graph. And then the last thing we need to do is press the graph button, which is here. Now both of us are looking at the actual graph of h of x is equal to e over x to the power of 5. You can see that the graph is a hyperbola with two curves facing diagonally. We can determine the end behavior of this graph function. So the end behavior is as the x values reach positive infinity, the values of h of x reach 0, and as the x values reach negative infinity, the values of h of x reach 0 again. 0 means y equals 0 or the x-intercept line. Notice that the values of h of x or the y values do not actually touch y equals 0. They go in a very flat line that we call asymptotes, and these values are actually decimal points, such as 0.985, 0.785, 0.585, and 0.0425, and so forth. However, that is not the only end behavior that we can determine. We have to find the end behavior of these parts of the function. These lines reach a vertical asymptote of x equals 0, or the y-intercept line, and we have found the end behavior of the lines that reach the horizontal asymptote. So the lines over here are the horizontal asymptotes. So the end behavior for this portion of the graph function is as the x values reach x equals 0, the values of h of x reach positive infinity, and for this portion of the graph function, as the x values reach x equals 0, the values of h of x reach negative infinity. There are actually 4 end behaviors in a hyperbola like this one on the graph. Now we have found both end behaviors of the two functions in our problem, and thanks to the help of our graphing calculator, we are able to see the graph of the second function that is complicated to visualize, finding its end behavior right away. And our problem is solved.